The focus of this video is on solving trig equations, what we would term maybe like the level 2 equations, essentially because they are quadratic in nature. The method that we would use to solve these trig equations are to take the square root. So I have 4 examples, and then there are 6 practice questions that I have the answers to show you at the end. So if we look at question 1, remember our intent is to take the square root, and to do that we need to isolate the square. So how we're going to do that is we're going to move this tangent function over to the other side. My intent is always to make the tangent or the squared term always positive. So I'm going to move it to the left because it'll be positive then. So I'm going to subtract tangent squared from the right to the left. This is just like combining like terms, if you would. So you would have 2 minus 1, which is 1 tangent squared theta, equal to 1 because this canceled. Once you do that, once you get the trig function squared isolated, then you would take the square root. And when you do that, you are getting tangent theta equals, and remember when you take the square root, it could be its positive or negative version. So we're looking at where is tangent positive or negative 1. In my unit circle, remember that tangent is equal to 1 or negative 1 when the coordinates are almost the exact same thing, but they could be of different signs. So today in this video, we're gonna deal with all degrees. So we're saying 45, 135, 225, and 315. 4 answers as to where that would be the case. So your final answer then would be theta equals those 4 angles. And it's beneficial to just move around the circle in that way. So this is what would make that true, okay? If that's hard for you to visualize or focus on, you can do variable replacement. So what I mean by that is once you see the function that's there, which is tangent, you can say that tangent theta is going to be x, and then you can actually use x as your method of solving. So this would be 2x squared equals 1 plus x squared, and then solve it just like you would any other quadratic. So x squared equals 1, take the square root, x equals plus or minus 1, and then sub back in tangent theta equals plus or minus 1. So it just kind of depends if the trig function is too much for you. Just sub out and put in x or whatever variable is your jam. All right, as we move into the next question, again, remember we're going to isolate cosine squared. So in my effort to isolate that, I'm going to add first because we would use opposite PEMDAS. So if I add the 4 to both sides, I get negative 1 is equal to negative 4 cosine squared theta. These two, negative 4 and cosine, are joined by multiplication. So I'm going to divide, do the opposite. I'm not going to get the decimal form of that. That's not helpful as decimals are not on the unit circle. So 1/4 is equal to cosine squared theta. When I go to solve that, I want to take the square root. And when you take the square root of a fraction, you essentially want to take the square root of the top and the bottom. So the square root of 1 is 1. The square root of 4 is 2. Put my plus minus in front. And now I have cosine theta. So cosine, remember, is x. So I'm looking for where x is 1/2 on the unit circle. So changing my color here, I've got an x value of 1/2 here, x value of 1/2 here, oops, wrong one, sorry, x value of 1/2 here, x value of 1/2 here. So again, 4 answers, 60, 120, 240, and 300. So that's how you would answer this final question. All right, the next 2 examples bring in the reciprocal functions. I know we didn't focus on them yesterday, but they are back. The process is still the same though. You want to isolate, secant squared. So to do that, we're going to add 7 to both sides. 3 times secant squared theta, and divide by 3. So 4/3 equals secant squared theta. At this point, this is where you want to take the square root of the numerator and the denominator. So that would leave us with the square root of 4 is 2. Square root of 3 I'm going to leave. And secant theta plus minus. I'm actually not going to rationalize this because remember secant is a reciprocal function and it's the reciprocal of cosine, and cosine is x. So I'm looking for where x, because it's the reciprocal, right? I'm looking for where x is radical 3 over 2 plus minus, right? Because these two are reciprocals. So secant is equal to this when cosine is equal to this. So again, looking at my unit circle, where is x equal to that? Let me erase these highlighted marks. So x is equal here, 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 and here. Again, 4 answers. Are there always 4? No. It just kind of depends. It's somewhere between, it's between 2 and 4 usually. So 30 degrees, 150, 210, and lastly, 330. The last one, we would subtract 4 from both sides, getting negative secant squared equals negative 4. Divide by negative 1, and we get secant squared equals 4. When you take the square root, you get secant is equal to 2 plus minus. So this confused students earlier today. So this is, remember, the reciprocal of cosine, right? So, which is x. So if this is the reciprocal, if I flip it back over, I'll know what the original was. The reciprocal of 2 is 1/2. So I'm looking for where x is equal to 1/2, which is on the 60s, I believe. So your answer here would be 60, 120, 240, and 300. Okay? So at the bottom here, I have some practice problems that I'd ask for you to practice on. I did write the answers in. I'll kind of stop the video here for a second just so you could pause it here if you need to. I didn't show the work. If you have questions on the work, you can absolutely come and see me, bottom 2 here. But I'd encourage you to try them on your own and see if you could get the similar responses that I did. If at any time you have questions, please reach out.